Hi friends, welcome to my channel. Before going to the video, those who are not subscribed our channel, subscribe it and also click the bell button. In this video, we will see the next 20 questions, that is question number 61 to 80 of UGC NET Electronic Science question paper of December 2020 and June 2021 cycle. First question. The circuit shown in the figure is initially under steady state condition. The switch is moved from position 1 to position 2 at t is equal to 0. The inductance value is 4 Henry. The current after switching will be option A 1 plus 2 into e to the power minus 5t amps. Option B 1 plus 2 into e to the power minus 5t amps. Option C 2 into e to the power minus 5t amps. Option D 2 into e to the power 5t amps. Here the circuit is given initially before switching from position 1 to position 2. The switch was under steady state condition. So after switching from position 1 to 2, the current will be given by I of t is equal to I of infinity plus I of 0 plus minus I of infinity to the power e power minus t by tau. Here tau is the time constant. For an RL circuit, the time constant tau is nothing but L by R. L is equal to 4 Henries, and when the switch is in position 2, the two resistance R1 and R2 will be in series, so they get added up. So 10 plus 10 is equal to 20 ohm. So tau is equal to 4 by 20 is equal to 0.2 second. Now before switching, that is at t is equal to 0 minus, the inductor will be in short circuit position. Because under steady state, inductor is short circuited, and under transient condition it is open circuited. So before switching, the current through the circuit is I of 0 minus is equal to 20 by 10, which is equal to 2 amps. Here the resistor R2 is not included before switching. Now after switching to position 2, at that instant, that is transient condition, t is equal to 0 plus, inductor will be open circuited. So after open circuiting, the current through the inductor will be 0, but inductor will not allow sudden change in current. So the current at the instant immediately after switching or transient condition is equal to 2 amps only. And at steady state condition, that is after long time after switching, at t is equal to infinity, current at infinity is equal to 0 amps. Even though at steady state the inductor will be short circuited, current through the circuit at infinity is 0 amps because before that it was open circuited, and that inductor will not allow sudden change in current. So current at infinity is equal to 0 amps. Now substituting the values in the given equation, we have I of t is equal to 2 into e to the power minus 5t amps. Hence option C is the correct answer. Next question. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion. A reflex klystron is a single cavity high power generator of efficiency 90%. Reason. The loop gain is unity with a phase shift of multiple of 2 pi. Here if you see, the assertion is wrong because reflex klystron is a low power oscillator. And the reason, the loop gain is unity with a phase shift of multiples of 2 pi is correct. So Assertion is not correct, but reason is correct. That is, option D is the correct answer. Next question. If the data segment register DS contains 4000 H, what physical address will be the instruction move AL, 234BH read? Here if you see, the physical address is given by the formula ds into 10H plus offset address. So this will be equal to 4000 into 10H plus 234BH, which is equal to 4234BH. That is, option B is the correct answer. Next question. Which of the following statements are correct? First one, DSB-DS, that is double sideband suppressed carrier modulation, is well suited for point-to-point communication involving one transmitter and one receiver. This statement is correct. Next statement, vestigial sideband modulation, VSB modulation, is a linear modulation scheme. This statement is also correct. Next statement, SSB is a non-linear modulation scheme. That is, single sideband is a non-linear modulation scheme. This statement is wrong because it is a linear modulation scheme. And the last statement, frequency modulation is a linear modulation scheme. This statement is also wrong because it is a non-linear modulation scheme. So, only statements 1 and 2 are correct. So, option B is the correct answer. Next question. Which of the following statements regarding the Fourier series are correct? First statement. For an even symmetry, only sine terms exist. This statement is wrong. Next one. For an even symmetry, only cosine terms exist. This statement is correct. Then, for an odd symmetry, only cosine terms exist. This statement is also wrong. For an odd symmetry, only sine terms exist. This statement is correct. So, in Fourier series, for even symmetry, we have cosine terms, and for odd symmetry, we have sine terms. So, only statements 2 and 4 are correct. So, option C is the correct answer. Next question. In a multimode fiber, step index fiber, number of modes passing at an operating wavelength of 1300 nanometer are 1000. The refractive index of the core is 1.50 and that of cladding is 1.48. The value of the core diameter is option A 100 nanometer, option B 75.8 micrometer, option C 2.5 micrometer, option D 6.25 micrometer. Here if you see, the number of modes in a multimode fiber, step index fiber is given by the formula n is equal to V square by 2. V is nothing but the normalized frequency or V number. So substituting n is equal to 1000, we have V is equal to root of 2000, which is nothing but 44.72. Next, the V number or normalized frequency is given by V is equal to pi d divided by lambda into root of n1 square minus n2 square. Here n1 square and n2 square are the refractive indices of core and cladding. Root of n1 square minus n2 square is nothing but the numerical aperture. D is the core diameter and lambda is the wavelength. Now rearranging, we have D is equal to lambda into V divided by pi into root of n1 square minus n2 square. Substituting lambda is equal to 1300 into 10 to the power minus 9 and V is equal to 44.72 and n1 is equal to 1.5 and n2 is equal to 1.48. We have the core diameter as 75.79 micrometer. So option B is the correct answer. Next question. It is match the following type. List 1. Diffusion. It is given by the equation, differentiation is related to the equation dou C of x comma t divided by dou t is equal to dou j of x comma t divided by dou t. Next, oxidation. It is related to Deal and Grove's model. Then UV resist. It is related to PMMA, that is polymethyl methacrylate. It is a synthetic resin produced from the polymerization of methyl methacrylate. Next, X-ray lithography. It is related to proximity printing because it is another type of optical lithography. So option C is the correct answer. Next question. An amplifier has power gain of 800. Its decibel power gain is option A 19 decibels, option B 28 decibels, option C 29 decibels, option D 30 decibels. The power gain in decibel is given by the formula P is equal to 10 log 10 800. We can write 800 as 8 into 100. So 8 is nothing but 2 cube and 100 can be written as 10 square. Now, bringing the 3 in front, we have 30 log 2 plus bringing the 2 in front, we have 2 into 10, that is 20 log 10, 10. Now, 30 into log 2 base 10 is nothing but 0.3 plus 20 into log 10 base 10 is 1. So, 30 into 0.3 plus 20, which is nothing but 9 plus 20, which is equal to 29 decibels. So, option C is the correct answer. Next, for parallel polarization in lossless dielectrics, the expression for Brewster angle for a wave traveling from medium 1 to medium 2 of refractive indices eta 1 and eta 2 respectively are. So, in terms of permittivity, the Brewster angle is given by theta is equal to sine inverse of root of epsilon 2 by epsilon 1 divided by 1 plus epsilon 2 by epsilon 1. So, option B is the correct answer. Next question. A differential equation is given as x of t plus 2 plus 3 into x of t plus 1 plus 2 into x of t is equal to 0. And they have given x of 0 is equal to 0 and x of 1 is equal to 1. The solution of this equation will be. So, to find the solution of this equation, they have given two condition, x of 0 is equal to 0 and x of 1 is equal to 1. So, substituting in the given options, first x of kt is equal to minus 1 to the power k minus 2 to the power k. Now, here if you substitute x of kt is equal to 0, we have minus 1 to the power 0 minus 2 to the power 0, which is equal to 1 minus 1 is equal to 0. Now, substituting k is equal to 1, we have x of 1 is equal to minus 1 to the power 1 minus 2 to the power 1, which is nothing but minus 1 minus 2 is equal to minus 3. Here we are getting x of 0 is equal to 0, but x of 1 is equal to minus 3. So, the two conditions are not satisfied. So, if you move on to option B and substitute k is equal to 0 and 1, we are getting x of 0 is equal to 0 and x of 1 is equal to 1. So, option B is the correct answer. If you want, you can check the other option C and D also. Here, for option C, x of 0 is equal to 2 and x of 1 is equal to 1. For option D, x of 0 is equal to 2 and x of 1 is equal to minus 3. So, option B is the correct answer because it satisfies the two conditions, x of 0 is equal to 0 and x of 1 is equal to 1. So option B, x of kt is equal to minus 1 to the power k minus minus of 2 to the power k is the solution of the above differential equation. Next question, if Ni and N0 are the corresponding speeds of the input and output shafts of a gear dynamometer respectively, and eta is the overall mechanical efficiency and the input torque tau I applied by mass m at a distance r is given by. So the formula for the input torque is tau I is equal to mg into r divided by eta into Ni divided by N0 minus 1. So option B is the correct answer. Next question, it is match the following type. List 1, ideal MIS diode, that is metal insulator semiconductor diode, N type. For this the equation phi ms is equal to phi m minus of x, that is electron affinity, plus Eg by 2q minus psi b. Psi b is the barrier height and Eg is the band gap energy, q is the charge of electron, and phi m is the work function of metal and phi ms is the work function of metal and semiconductor. Next, extrinsic d by length hole is given by the formula root of kt epsilon s divided by p naught q square. And next, the field dependent mobility is given by the formula mu into Ex divided by 1 plus mu into Ex divided by Vs. Then the transit time for velocity saturation is given by the formula L by Vs. So here option D is the correct answer. Next question, given below are two statements. Statement 1, the scaling theorem relates scale changes in frequency domain to the consequent changes in scale in the time domain. This statement is true. Then statement 2, the scaling theorem is not applicable to an impulse signal. This statement is also true. So here both the statements are true. That is statement 1 and statement 2 are true. So option B is the correct answer. Next, if Fm is the modulating frequency and MF is modulation index, then by the Carson's rule, the bandwidth of an FM signal at the input of a conventional discriminator will be 2 into FM into MF plus 1 Hertz. So option B is the correct answer. Next question, if an amplitude modulated wave 10 into 1 plus 0.6 cos 2 pi 10 cube t into cos 2 pi 10 to the power 60 is to be detected by a linear diode detector, then the time constant will be option A 0.17 millisecond, option B 0.17 second, option C 1.7 millisecond, option D 17 millisecond. So the solution is the required condition for the detector output to follow the input all the time is the time constant RC should be less than or equal to 1 by omega m into root of 1 minus mu square by mu square. So mu is the modulation index and omega m is the angular frequency of the message signal. Omega m is nothing but 2 pi 10 cube. So substituting omega m is equal to 2 pi into 10 cube and the modulation index is 0.6 from the standard time domain equation. So substituting mu is equal to 0.6, we have RC should be less than or equal to 0.212 millisecond. So the approximate answer will be 0.17 millisecond because it is less than 0.212 millisecond. So option A is the correct answer. Next question, match the following. List 1 they have given f of t and list 2 f of s, that is the Laplace transform of f of t. So option A, first one, e power minus et, it is nothing but 1 by s plus a. T into e power at, it is nothing but 1 by s minus a the whole square. It is just the application of formula. Sin omega t is equal to omega divided by s square plus omega square. Cos omega t is equal to s divided by s square plus omega square. So option D is the correct answer. Next question. Broadside arrays have number of dipoles of unequal size. This statement is wrong because in broadside arrays number of dipoles are equally spaced. So second statement is correct. And third one, collinear dipoles. So this statement is also correct. And fourth statement, dipoles are in phase. So this statement is also correct. And the last statement, dipoles are 90° out of phase. It is wrong. So for broadside arrays, dipoles are equally spaced, they are collinear and they are in phase. So statements 2, 3 and 4 are valid. So option C is the correct answer. In JFET, that is junction field effect transistor, the current density in the x direction is given by formula sigma of x into E of x and Q into Nd into mu into Ex. Here mu is the mobility and Nd is the carrier concentration, Q is the charge of electron, sigma is the conductivity. So statements 1 and 2 only are correct. So option A is the correct answer. Next question. Given below are two statements. Statement 1. By bringing together the computational capability of microelectronics with the perception and control capabilities of miniaturized sensors and actuators, MEMS technologies are enabling smart systems on a chip to be mass produced. So this statement is absolutely correct. And if you see the second statement, while considering IoT deployment, data integrity and authenticity are no more security concerns at the sensor node level. So this statement is wrong. So statement 1 alone true, but statement 2 is false. So here option C is the correct answer. And the next question, the Schottky effect is the image force induced lowering of the potential energy for charge carrier emission when an electric field is applied. Here the attractive force called image force is given by the formula minus Q divided by 16 pi into epsilon naught into x square. So option C is the correct answer. Thanks for watching the video. For more videos, don't forget to subscribe our channel.